Right, okay, so this is the grade 9 lesson. So what we're going to do today is to look at solving simultaneous equations, but we're going to have a little look at doing this graphically. So to do now task, you can pause it, but what we're going to do is I'm just going to go through solving these questions. So the first one, we can see the x's are the same. Because the signs are different, I'm going to add them together. They'll cancel out. 4 plus 5 is 9y. 0 plus negative 9 is negative 9. You have to excuse me, I'm a little bit sick today. Divide both sides by 9. Y equals negative 1. So then I'm going to substitute that back into any of the equations. I'm going to pick the top one. So negative 2x plus 4 times negative 1 is 0. Negative 2x is going to equal minus 4 is 0. Bring that 4 to the other side, it'll become positive. Divide both sides by negative 2, and x equals negative 2. Next one, same again, we're going to add them together, so they'll cancel out. 3 add negative 4, so a positive and a negative make a negative, so it's going to be negative y. And then 1 plus negative 2 is going to be negative 1. So that means y equals positive 1. Put that into any of them. 2x plus 3 times 1 equals 1. 2x plus 3 is 1. Bring the 3 over here. So you're going to subtract the 3. So 1 minus 3 is going to give you negative 2. Divide both sides by 2, and then x is going to equal negative 1. Right, this last question over here, I want us to do it using a substitution method. So because we know what x is, we know that's here, we are going to just substitute that into the y. So 5x minus 2, sorry, that was wrong. Never mind, we're going to substitute it into the x, sorry. So 5 times a fifth y minus 27 over 5 minus 2y equals negative 29. So if we times everything by 5, you're going to have y minus 27 minus 2y is negative 29, because them 5s will cancel out on the bottom. If we simplified that, we're going to have negative y minus 27 equals negative 29. Add 27 to both sides. Negative y is going to equal negative 2, so y equals positive. Put it back into any of the equations at the top. I'm going to pick the second one. So 5x minus 2 times 2 is negative 29. 5x minus 4 is negative 29. Add 4 to both sides. 5x is going to equal negative 25. Don't have much space, but x equals negative 5. Right, okay, what are we going to do in today's lesson then? We're going to have a look at solving systems of equations by graphing them. So the first thing we need to remember to do, we did this a while ago now, is to be able to graph equations. So remember when you're doing this, this is the equation of a line. What's in front of x is the gradient, and the number on the end is the y-intercept. Intercept. Okay, so in this question my gradient is just 1, so that means rise over run is 1 over 1, and we're going to do that from the y-intercept here, which is 2. So that means I just rise by 1 and I go to the right by 1, and my line would look like this. You only need 2 points to graph your straight line. So we did this a while ago. Okay. Right, so now what we're going to do is, if you're asked to solve two equations, you can just draw them both on the graph, and wherever they intersect, that's the solution. So this is a different way of how we can solve simultaneous equations. So this first question I've just done, the y-intercept is 2, and the gradient is 1. So you rise by 1, run by 1. So it looks like this. Right, the second equation, there's two ways you can do it. You can either put some points in or you can rearrange it. So I'm going to bring the 3x over here. So y equals negative 3x plus 6. So that means my y-intercept is 6. But this time my gradient, my rise over run, is -3. So that just means instead of going to the left, I'm going to go to the right. So I'm going to rise by, so that's over 1, rise over run, but I'm going to go backwards just because I have no space. So instead of rising, I'm going to go down by 3, and then instead of running, I'm going to run to the left, and that should be like that. I'm going to show you the better version now, but where them two graphs cross is the solution. So if I just go down here, them two graphs will intersect there, that's where they cross. We are going to use a little bit of Desmos for this, which is okay. Yeah, and then there's more questions for you to try here in your own time. But what I'd like you to do now is, I'd like you to go to Assess Prep, and I'd like to give it a go. On Assess Prep, there's a video you can watch also, and I've also give you a graphing calculator so you can type these in yourself.